So last class we started unit 3. Those who are using your laptop or mobile phone, you can pin the slide. You can pin the slide so you can see it in full screen. So unit 3 lists that we started in the last class. So this is the introduction part. I think the strength is now only 12. You have to send your roll number and your name in the chat box, and I want to report it to the study center and they will put attendance for you. So just put your roll number and name in the chat. So in this unit we will see the abstract data type list, then array implementation of list, then linked list implementation of list, and doubly and circular linked list. So that we will complete today. In linked list, items can be added or removed easily to the end or beginning or even in the middle. In that we discussed array implementation of list, then abstract data type list that we have discussed in the last class. Then consider a real world problem, that also we discussed. Then array implementation of list. For that we are using structure. Then array implementation of list, we are using insertion and deletion of elements. So insertion is like this. Then deletion, we want to add 35 in between 33 and 44 that we discussed in the last class. Then deletion. So to delete an element in the list at the end, we can delete it without any problem. If we want to delete the element at the beginning or middle of the list, then what we want to do, we have to rewrite all the elements after the position where the elements are, that has to be deleted. Okay, so we went through this portion also. So this is a new topic, that is linked lists implementation. The linked array implementation that we already discussed. The linked list is a chain of structures in which each structure consists of data as well as pointer. So what is linked list? Linked list is a chain of structures in which each structure consists of what? Two parts. The first part is called the data part and the second part is called the pointer part, which stores the address. The pointer stores the address, that we call it as link of the next logical structure in the list. So a linked list is a chain of structures in which each structure consists of a data part and a pointer part. Data part means one data, for example, one name or one roll number, or that we call it as the data part. Then the pointer part means it stores the address, that we discussed what is address in the last class, that we call it as link of the next logical structure. For example, when we are using array, we want to store the roll numbers of 3 persons. So this is the roll number 101 is the roll number of the first person, and 102 is the roll number of second person, 103 is the roll number of third person. So here when we are using this by using a list, the list here, the data part is 101, that is the data part, 102 that is the data part, and 103 is the data part, that is the roll number. And the pointer means, for example, here we stored this in the memory address 500. So it's an integer type data. So the memory reserved for storing the integer data is 2 bytes. So 500 and 501 is for storing 101, and 502 and 503 is for storing 102, and 504 and 505 is for storing 103. So this is called this is 500, 502, 504, that is stored the address part, that is the address part. of the next logical structure in the list. So 101, that is the first logical structure. So 102 is the next data. The pointer or the address for storing that 102 is 502, and the data 103 is stored in the address location 504. I think it's clear. Then a linked list is a data structure used to maintain a very important thing, dynamic series of data. So a linked list is a data structure used to maintain a dynamic series of data. It's not static series of data. It's a dynamic series of data. Then what's the difference between a dynamic series of data and a static series of data? In array, we are using a static series of data. That means we have to predefine the array. Means before using that array, we have to declare the array. So the array is static data structure. That means if we declare if we want to use an array, we should declare it prior to use it. We have to specify the data type. We have to specify the memory space required. That all that we have to declare before using it. So we can say it as a static series of data. But in linked list, we are using a dynamic series of data that we are discussing. So linked list, there are different types of linked lists are available. The first type of linked list that we can say are singly linked list. We can say a singly linked list. So here one example is there, 1000. You can see here 1000. 1000 is the starting memory address. So this is pointing to this start, or this 1000 is represented here. This is the starting memory address. We point it to the memory address, that is start. What is start? Start is the starting memory address, that is 1000. In that 1000 memory address, we stored the data, that is Madan. This is the data that we stored in the 1000 memory address. And the second part that we already discussed, that in a singly linked list, two parts are there. The first part is called the data part, and the second part is called the address part. So the first part is called the data part. For example, here it is displayed like this. The first part is called the data part, something like a Madan. And second part, that is the address part, that is 1050. That is the address part. Means what? The second data is stored in the memory address 1050. I think it's clear. A linked list consists of two parts. First part is the data part, and the second part is the address to which where we want to point to the next data. The address of the next data is stored in the address part. So when we are looking 1000, that is the location where the linked list starts. So this is the memory address. From here we are starting. This is the memory address. From here we are starting. And this memory address, we stored the data, that is Madan, and we stored the address of the next data item, that is 1050. Then what will happen? When we are looking the next data, it will look to the memory address 1050. So these are the memory addresses. These are the memory addresses. So the first part, the first memory address is 1000, and the start points to 1000. That means the linked list starting from the memory address 1000. In that 1000 memory address, we have the data, that is Madan, and the address part, we have the memory address 1050. Okay, and it will look what is in the 1050 memory address. What is in the 1050 memory address? In 1050 memory address, we have the data that is Mohan and it points to the next data item's memory address. What is the next data item's memory address? That is 1200. Then what will happen? It will point to 1200. So from here it will point to 1200. In the memory address 1200, what is the data in 1200? The data in 1200 is Babu, and what is in the address part? Address part means the next data item, that is the address part where the next data item is stored. So here that we can see null is the uh, uh, in the address part we can see null means what? Null means this is the end of the list. When we found null in a series, that means this is the end of the address, or this is the end of the list. I think it's clear. So I'll explain it once more. When we are using linked list implementation, there are different types of linked lists are available, and the first type of linked list is singly linked list. The first type of linked list is singly linked list. Singly linked list consists of two parts, one data part and one address part. One data part and one address part. Then what is in the data part? The data part contains the actual data. The data parts contains the actual data. Then what is in the address part? The address part contains where the next data value is stored. Where the next data value is stored. So here you can see, for example, this is one example for a singly linked list. So start means the bottom portion you can see the memory addresses. The bottom portion that you can see the memory addresses. So start means we want to start with a memory address. We want to start with a memory address. So the starting memory address is, what is the starting memory address? The starting memory address here is 1000. So it will allocate the first memory address 1000 for storing the first data value. So the first data value that we want to store is Madan. So we store the data value Madan in the memory address 1000. So in a singly linked list, two parts is there. The first part contains the data part and second part contains the pointer. So the first data part points to the next data part memory address. Then what is the next data part memory address? The next data part memory address is 1050. Then what will happen? It will move. It will search the memory address 1050 for the next data value. Then what is stored in the memory address 1050? In the memory address 1050, it stores the next data value, that is Mohan. Again, that data part also, that structure also have two parts, the data part and the address part. The data part is Mohan and the address part. What is the address part? Address part is used for finding the next data value. So the address part here is 1200. So it will point to that memory address 1200. What is the data value that is stored in 1200? In 1200 it stores the data value Babu. Then that also has two parts, that is the data part and the address part. In the address part, there we can see no that memory address is there. We can see the constant null, NULL. Null means this is the end of the list. I think it's clear. So this is the singly linked list. So start is a pointer which is pointing to the node which contains data Madan. Start is the pointer. So start is the pointer that points to the first memory address, the first data values memory address. So start is a pointer which is pointing to the node which contains the data, which contains the data. What is stored there? The data value stored in memory address 1000 is Madan. And the node Madan is pointing to the node Mohan. Okay. So the Madan data part, this is the data part Madan, it pointing to the memory address 1050, and that memory address we can see the data value. What? You can see the data value Mohan, and the last node Babu is not pointing to any node. It is not pointing to any node. Means what? That is the end of the list. So below that you can see 1000, 1050, 1200 are memory address. I think it's clear. So we are moving to the next part, that is the algorithm insertion of elements into a linked list. So insert element into a linked list. This is the algorithm. All of you are familiar with algorithm. Algorithm means what? Step by step approach of a problem. So we are giving the first step with begin, and we stop with the last step with end. So step 1, we want to begin the algorithm. So step 2, if the list is empty, there is one possibility, maybe the list is empty. So when the list will be empty, nothing will be there. We are going to create a new list. Then the list will be empty. So if the list is empty or a new element comes before the start we call it as head element. Then insert the new element as start element. So if the list is empty or we created it but no element is there, in that case what we want to do, insert the new element as the start element. Then if the list is not empty, then if the new element comes after the last element, means we want to insert the element at the end or as a new element as the end element. Then what we want to do, insert the new element as the end element. This is the two possibilities. First one, the list is empty, or the list is there but no element is there. So if so, we want to insert the new element as the start element. And the second case, the list is there, elements are there, we want to insert a new element as the end element. Then what we want to do, insert the new element as the last element or end element. Yes, insert the new element in the list by using the find function. So the list is not empty, some elements are there, and the element that we want to insert is not as the end element. Means what? We want to insert the element in between the list. If so, insert the new element in the list by using the find function. Find function returns the address of the found element to the insert list function. So if we want to insert an element in between the list, what we want to do, we want to find the element where we want to insert the element. Sometimes it may set that in between this and this, or in we want to insert it in this memory address. So we want to find the location where we want to insert. So insert the new element in the list by using the find function. Find function returns the address of the found element. So it will return the address of the found element. We want to, so for example, if we want to insert in between, so we should find the element that we want to insert in between. So the first element that we want to find. So the find function returns the address of the found element to the insert list function. In that, if we want to insert it in between, then we can insert it, that we will discuss. So here when we are discussing, so after this I will say, so before insertion. So this is the list, first part, that's the list. Then one element is there, here one element is there, here what is the element that we can store here? The first part, we can store the data that we want to insert, that we can store here. And what here? This is the address part. Address part of what? Address part of the next element. So for example, this is the first element and this is the second element. For example, we can give some data here. So we can give some data here. we are giving the data capital A, small a here. So this is the data. So before giving the data, there we should have an address. For example, 1000 is the memory address it is pointing, that's the start address. So here it will be the memory address 1000. And this is the second data element. Here we store the data value capital B, small b. And the memory address here is 1200. This is the memory address. The first data stored in the memory address 1000, that is the start element, and the second memory address, that is 1200, that is the second memory address. There we stored the data value BB. The first data value is AA and second data value is BB. So we want to point, this is the first data element and this is the second data element. Then how we can point to the second data value? How we can point it? Here in this portion we want to give the memory address of the second data value. What is the memory address of the second data value? This is the memory address of the second data value. What is that? 1200. So what will happen? It will point automatically to the memory address 1200 and take the data value what is there, that will take. So BB is the data value. Then in the second node also we have two parts, that is the data path and the pointer path or address path. Then here where it is pointing, it is pointing to the null, means what? This is the end of the list. So here we can give the address as null. Null means it is the end of the list. Okay, I think it's clear. So this is the before insertion, this is the data structure. And we want to insert a new data element. The new data element that we want to insert is, for example, Z is the data value. Want to insert in between AA and BB. We want to insert the data value Z. So how we can insert it? The first data, after insertion, the first data value we want to point to the first data address, that is 1000. Start is 1000. So this part is the memory address that is hold the data, the address 1000. So the data value here we are using is capital A, small a. And the next memory address is, what is that? Here that is 1200. In 1200 the data value is capital B, small b, and this is the end. So we give the address part as null. And we want to insert a new data element Z, and Z is stored in the memory address. For example, it's stored in the memory address 1500. For example, it's stored in the memory address 1500. So this is the new element. This is the new element. What is the data value over there? That is Z is the data value. So what is the memory address that holds this Z? The memory address that holds the memory address is 1500. This is the memory address. So we want to insert the data value Z in between AA and BB. How we can insert it? So here the next data element stored in the memory address 1200. So we want to break that 1200 with the new element's memory address. What is the new element's memory address? The new element's memory address is 1500. So that we want to give that 1500. Then what will happen? After AA, it will search for the next element in the memory address 1500. So it will automatically point to here. That is 1500. Then again from 1500 where we want to go? We want to go to where? 1200. So here we can give the memory address 1200. So it will automatically direct to the memory address 1200. There the data value we stored is capital B, small b. and after that it will point to the next element's memory address. What is the next element's memory address? So this is the end of the list. So we put there null. I think it's clear. So insertion, this is the algorithm for, this is the yes, this is the algorithm for insertion, and also deletion. So next one, deletion. We'll discuss how we can delete an algorithm. So I think it's clear. Again, once more, insertion algorithm, we can insert an element as the first element, last element, or an element in between. Element in between means the list is there and some elements are there. So we can insert elements in. These are the three conditions. So when we are inserting an element by using a singly linked list, in a singly linked list we have two parts. First part is the data part and the second part is the address part. The data part that holds the data, and the address part means the address of the next data element, where the next data element is stored, that is the address part. So insertion, it is very easy. The insert, if you want to insert an element in between, what we want to do, we want to change the memory address of the already inserted element to the newly inserted element. The address part we want to change from 1200 to 1500. So that is only the difference. Very easy for inserting an element, but if you are using this algorithm by implementing array, then it is very difficult. We want to shift the elements in between. We want to shift the elements in between to the right and put a new space and put the element over there. It is very difficult. So next one, algorithm, deletion of an element from the linked list. So step 1, I think you got the idea how we can delete the element. Step 1, begin, and step 5, end. Then step 2, if the list is empty, is it possible to remove an element from an empty list? No, it's not possible. Nothing is there, then how we can delete an element from there? So if the list is empty, then element cannot be deleted. Then step 2, else means what? The list is not empty. Then if the element to be deleted is the first node, then make the start, that is the head, to point to the second element. Very simple. If you want to delete the first element, then what we want to do? The head element should be point to the second element. Then it will automatically delete it. When we traverse, it will not traverse the first element. That is simple. Then else, delete the element from the list by calling find function and returning the found address of the element. So that we already discussed how we can use the find function. So if you want to delete an element in between, not the first element and not the last element, then what we want to do? We want to find the element that we want to delete. We want to find the element that we want to delete by using a function called find and returning the found address of the element. When we in that find function, along with that find function, we will get the address of the element that we want to delete. So we can change the address with the address of the next element. So we will discuss how we can delete an element from the list. For example, this is the element. For example, after deletion, it will like this. So figure 3.4, deletion of an element from the linked list. Dotted line depicts the link prior to deletion. I will explain. So earlier that we discussed that the first data element, that is in 1000, memory address 1000. So here we can say that points to the first memory address, that is 1000. This is the memory address, that is 1000. What is the data value over there? The data value was capital A, small a, that is the data value. Then it points to the next memory address. What is the next memory address after insertion? The next memory address after insertion is 1500. What is the data value over there? Z is the data value over here. And the next memory address, that is 1200. So this is the memory address, that is 1200. What is the data value over there? Capital B, small b, and this is the end of the list, so we denoted it with null. So this is the initial element. Then here we want to, here the first element, what we want to add here, we want to add here the data, the address part of the next data element, that is 1500. And what we want to give here, here we want to give the next the address of the next data value, that is 1200. I think it's clear. So it will start with the data with the address part, that is 1000, and from 1000 the data value, in 1000 the data value is AA, and it will point to the next data value with the address of that data value, that is 1500. So it will move to 1500, it will take the data value. The data value in 1500 is this set. Then after that it will move to the next address. The address that it is pointing to is 1200, so it will point to the address part 1200. The data value over 1200 is BB. So we can simply say that, we can simply write capital A is the first list item, then Z is the next list item, so B is the next list item. Then after this, this is the end of the list, so point the null address. So this is the first part. Then we want to delete Z, that is the dotted part that we want to delete. This much of portion that we want to delete. So how we can delete a data item from this linked list? We want to, when we are deleting this element, in our list we have only AA and BB. Okay. So from AA we want to point the memory address of BB. So how we can point it? We can remove this 1500 with the data value of BB, the address of BB, that is 1200. So what will happen? It will directly point to here. Then what will happen? It will be automatically removed. Right? So this is the algorithm. So from here we are, from 1000, the next memory address that we want to refer is 1200. So it will move to 1200. Then the next data value is null. That means that is the end of the list. I think it's clear. Okay. So the deletion algorithm and the insertion algorithm that we have discussed, two things that we have discussed. First part, what is this data item, and the algorithm of insertion and deletion. In your text, one more part is there, that is the program part. The first part, I took all the things for the slide preparation is strictly from your text only. So all these elements are, all these things that you can find in your text, that is IGNOU text block 1. So the first part, that is the algorithm, and second part, that is the illustration, and the third part is the program that is there in your text. So you have to go through that program. You have to type it in C compiler and try to run it and find out the result. So when you are coming to the lab, if you have any doubt, we can clear it over there, and you can start writing the lab manual questions in your code book also. So first we want, before writing, you have to do it by yourself. So algorithm that we discussed, and the illustration that is also discussed. After this insertion and deletion, after the algorithm, you can see the program. Program is there. You can type it and run it by using the C compiler. Okay. Next one, doubly linked list. In the beginning, I told you that different types of linked lists are there. The first one that we have discussed is singly linked list. In singly linked list, one data part and one address part is there. So in doubly linked list implementation, in a singly linked list, each element consists of a pointer to the next element. So what is the disadvantage of singly linked list? Disadvantage of singly linked list. Traversing is possible only in one direction. Traversal is possible only in one direction. So, for example, this is the singly linked. We can traverse the next element. We can traverse simply the next element, but it is not possible to traverse backward. Backward traversal is not possible in what? In singly linked list. So each element consists of a data pointer, consists of a pointer, a single pointer. So traversal is possible only in one direction, that is forward traversal is possible. Sometimes we have to traverse the list in both directions. For example, the first data element that we stored in the 1000 memory address is AA, and the next memory address that is 1500. There we stored the ZZ, and that is directed to 1200, and the 1200 address part we stored the BB data value, and this is the end of the list. So here 1500. So it will traverse here, and after that it will traverse here. Forward traversal is possible. Is it possible to backward traversal from BB to ZZ, from ZZ to AA? In singly linked list, it is not possible. In singly linked list, it is not possible. So sometimes we have to traverse the list in both directions. That means forward direction and backward direction to improve performance of algorithm. To enable this, we require links in both the directions. We request links in both the directions. That is, the element should have points to the right element. The elements should points to the right element as well as the its left element. So this type of linked list is called doubly linked list. Double means two pointers and one data item. I think it's clear. So we require links to both the directions. That means the element should have points to the right element as well as the elements have to point to the left element. So this type of linked list that we call it a doubly linked list. So doubly linked list implementation, you can see here the second part. Just go through the second part. This is the data part. Then this is the left link, address of the left data item. This is the right link, that means the address of the right data element. So this is the structure of a doubly linked list. I took this image from your text, so it's there. So doubly linked list that you can see in figure 3.5 is defined as a collection of elements. Each element consists of three fields. So doubly linked is a collection of elements, and each element consists of how many fields? Three fields. The first field pointed to left element. This is the first field. That is the pointed to the left element. The second field is the data field. So this is the second field. This is the data field. Then pointed to the right element. This is the third field, that is the pointer to the right element. I think it's clear. Left link of the leftmost element is set to null. So left link of the leftmost element is set to null. Why? This is the link is starting from there. That is the first address. The left link of the leftmost element is set to null, which means that there is no left element to that. From this element, there is no left element. From this, there is no left element. Then, and right link of the rightmost element is set to null. Right link of the rightmost element is set to null, which means that there is no right element to that. So, in the right part, there is no right element. So, this is the end of the list, and this is the beginning of the this data part is the first data part. This is the beginning. Before that, there is no link. So I think it's clear. Then algorithm, doubly linked list creation algorithm. First step, that is begin, and the last step, that is end. So in second step, define a structure for linked list, we are using structure. I think all of you are familiar with this structure. And what is the use of this structure? By using a structure, if we are using a array data, then we can use only single data element. For example, int a of I means we can store only integer type of data in the array. We can store only integer type of data in that array. That means we can store the elements in single data type, same data type elements that we can store. So to overcome this, if we want to store mixed type of elements, we have to declare a structure. In structure, we can define multiple data items. It may be first one, it may be an integer, or the second one, it may be a character or float. Mixed data elements that we can use in structure. So define a structure element with fields data, store the data value, left pointer for store the previous element's address, and the right pointer for storing the next data item's address. So when we are declaring, for when we are creating a doubly linked list, we should have three data elements. First part, that is the data element to store the actual value, and the left pointer for pointing the previous element's address, and the right pointer is used for storing the next memory location, the next element's memory location. So define a structure with these three elements. Then step 3, declare a pointer by name head. We already discussed what is the use of this head. That is the head is the first data element that we stored in head, and by using malloc function. I think you already studied this malloc. What's the use of this malloc? For allocating memory allocation. Malloc function. So it's used for memory allocation. Allocate space for one element and store the address in head pointer. So first step, declare a pointer with the name head, or you can use any name by using the memory allocation function malloc. Then allocate space for one data element. One data element means in that one data element we should have three items. First data item, and the left pointer and the right pointer, and store the address in the head pointer. And we can store the address. We will get the address from the function malloc, and we want to store it in the head element, head pointer. So this is the way that we can declare head equal to, you can use small letter or capital letter, equal to element in, what is this? This is what it means. It is a pointer. So element malloc of size of element. What's the use of this function size of? Size of function is used for getting the total memory size required. For example, one integer and one char. Integer, it requires 2 bytes, and char, it requires 1 byte. So total 3 bytes. So size of will get 3. So head equal to elements, we call it as, simply we can say element star. That is the pointer. Element is it's a pointer. Then malloc of size of element. So size of element will get the total size of the size required, and that much of size will be allocated in memory by using the malloc function. The next step, read the value for head arrow data. Read the value. We want to read the first data value by using the head arrow data. Then head arrow left equal to null. Why? Head arrow left equal to null means in the left side of the head, what is in the left side of the head? In the left side of the head, it will be null. So head arrow left equal to null. Head arrow right equal to, again equal to element malloc of size of element. We will get the size of the total size of the element. If we are declaring like this, then it will be 3 size. Then that much of memory will be allocated, malloc of 3 bytes, and it will store the address will store in the pointer variable. So step 5, repeat step 3 to create required number of elements. We can repeat the step 3. For example, if you have 3 data elements, we can repeat this 3 times. So we will get enough memory space and allocation. So this is the algorithm for creating AEE linked list. The next one, circular linked list. Circular linked list implementation. A linked list in which the last element points to the first element is called a circular linked list. So here we can see that this is the first element. These are the second element. We may have the required number of elements we can insert, and this is the last element. So if we want to traverse from the last element to the first element, this is two-way traversal is possible. So if we want to traverse from the last element to the first element, for example, we have, this is the data values 12, 13, 14, 15, 16. These are the data values. From the first element 12, we move to 13, 14, 15 and 16. And if we want to move backward to 12, how many times that we want to traverse back? From 16 to 15, 1, then 15 to 14, then 14 to 13, then we can move to 12. So if we are using a circular linked list, means the last element will point to the first element. That is called the circular linked list. If so, the traversal, backwards traversal, it will be easy from the last element to first element. So circular linked list means a linked list in which the last element points to the first element. The last element points to the first element is called a circular linked list. The chains do not indicate first or last element. That means there is no first element or there is no last element. In a circle, there is no first or last. For example, this circle, there is no first or last. So the chain do not indicate first or last element. Last element does not contain the null pointer. Why? The last element will point to the first element. So there is no null pointer. The external pointer provides a reference to starting element. So the external pointer provides a reference to the starting element. Where it starts, it will point to the external. When we are creating, we want to start from a point, from an address. So the external pointer provides a reference to start element the first time. The possible operations on a circular linked list are, we can use insertion, we can do deletion and traversal. So insertion is possible, deletion is possible, and traversal is possible. So figure 3.6, we can see the circular linked list. So this is the head that we called as the external pointer provides a reference to the start element. This is the start element. And from here, for example, this is the start element. So 1000 is the start element, for example. So this is 1000. And this is the first data element AA. And for example, this is the second data element is Z. Sorry. Second data element, that is Z is here. And this is the third data element, that is BB is here. So this is singly circular linked list. So here the memory address 1000, here the 1500, and here 1200. So how we can link? So here in AA we can give the pointer as 1500. In ZZ we can give the pointer as 1200. And normally we are giving here as null. So in circular linked list, we are not giving here null. Instead of this null, what we want to do? We want to give the first memory address, that is 1000 over here. Then it will directly point to the memory address 1000. From 1000 it will point to 1500. From 1500 it will point to 1200. From 1200 it will point to 1000. So it is called the circular linked list. So insertion is possible in circular linked list, deletion is possible in circular linked list, and traversal is also possible in circular linked list. So the algorithm, insertion of an element into a circular linked list. So first step begin and last step end. Step 2. If the list is empty or new element comes before the start or head element, then insert the new element as start element. Normal way. Then else, if the new element comes after the last element, then insert the new element at the end element and adjust the pointer of last element to the start element. This is the difference. So insertion, that is normal. If the new element comes after the last element, then insert the new element at the end element. That we know how we can insert. And adjust the pointer of the last element. Normally, we are giving the pointer, the address of the last element is null. So instead of that, and adjust the pointer of last element to the first element that we illustrated here. We want to if we want to insert after this we want to insert an element, then what we want to do after this we want to insert an element that is CC. So here we are inserting the element as CC, and the CC is in the memory address 1250, and we want to point this 1000 to 1250. Then what will happen? It will point to here. This is the new element. From the new element, that is the end element, we want to point to the first element. That is here. We want to point to the first element. So it will move to here. It will point to here. Okay. So point to the last element to the start and adjust the pointer of the last element to the start element. Else, insert the new element in the list by using the find function. If we want to insert the new element not in the beginning and not in the end, if we want to insert the new element in between. So insert the new element in the list by using the find function. We want to we can use a function called find. By the find function is used for finding the location where we want to insert, or in between, or after we want to get the element by using the find function. Find function returns the address of the found element to the insert list, and where we want to insert, after that element or before that element we can insert. We will get the address and we can insert. That we know how we can insert an element. So insertion of element circular linked list. If new item is to be inserted after an existing element, then call the find function recursively to trace the key element. So the new item is to be inserted after an existing element. Then what we want to do? We call the find function recursively to trace the key element. Recursively means what? Recursion. I think all of you are familiar with the function recursion. Recursive function means a function called by itself. That type of function we call it as a recursive function. Recursively to trace the key element. We want to find the key element. The new element is inserted before the key element by using the above algorithm. So you have to insert the new element before the key. Key element means what? Where the element that we want to insert. Before we want to insert the element after the key element. So we want to find the key element, then new element is inserted before the key element by using the above algorithm, or after. If we want to insert the element after, then we can also insert over there. Then figure 3.3 depicts the circular linked list with a new element that is to be inserted. 3.8 circular linked list with the new element inserted between first and second element. That is the two figures. So 3.7 circular linked list with a new element that is to be inserted. Insertion circular linked list. For example, first part, this is pointing to the memory address 1000. I am using 1000 for simplicity. For using simplicity, you can use any memory address. Simply, I am using 1000 as a memory address, starting memory address. So here, this is the memory address, that is 1000. And I am repeating the same elements because that you want to understand. You can use any element. You can use any memory address. You can use any element over here. There is no problem. For example, AA is the first element that we want to insert, and BB is the element that we want to insert, and Z is the new element that we want to insert. For example, we are inserting the items in this list. So first element, what is the first element? That is AA. What is the next element? That is BB. Then AA is in the memory address 1000, that is the head or starting memory address, and BB is the memory address 1200, and we want to insert a new, this is the way, and this is circular linked list. So what we want to do, we want to give here, we want to give the first memory address, and circular linked list with the new element that is to be inserted. The new element that we want to insert is Z. This is the new element that we want to insert. So this is the new element. New element is in the memory address 1500, for example. So normally we are using 1200 here. So first element AA, second element BB, and again it's a circular linked list, so it refers to the first element. So here we want to insert a new element. The name of that new element, the element that we want to insert is ZZ, and this ZZ is in the memory address 1500. So what we want to do here, we want to change the memory address as 1500. Then what will happen? This will break and it will point to this address. Then from here we want to insert not null. We want to point to 1200. So it will point to here. Then from here it will point to the first element. So here we inserted a new element in between other elements. We inserted a new element in between other elements by using this circular linked list algorithm. So 3.8, a circular linked list after insertion of the new element between first and second element, that we already discussed this one. So this is 1000, means we want to insert the first element in the 1000 location. The element that is in 1000 location is AA, and this is BB. This is in 1200. For example, this is ZZ. Is in the memory location 1500. So here normally we are referring it to 1200. So it will direct to here. And we want to insert the new element in between the first element and the last element. So we are removing it. Now it becomes dotted lines. So dotted lines depict the links prior to insertion. Then from here, we are instead of 1200, we are using 1500. I think all of you are familiar with this. From here, we want to refer here. Instead of this null, we are referring it to 1200. So it will refer this one. Then because it's a circular linked list, we want to give the memory address of the first element. I think it's clear. Algorithm deletion of an element from a circular linked list. So step 1 begin and step 5 end. If the list is empty, then element cannot be deleted. That we already discussed that from an empty list it is not possible to take out an element. Then step 3, else, means the list is not empty. If element to be deleted is first, then make the start head to pointer to the second element. That's a simple thing. If you want to delete the first element, then what we want to do, just change the address to the head element to make the head element, the second element as the head element. Simply we can draw it. For example, this is the first element. Normally we are giving it as 1000 and the value is AA, and this is the second element. Here we are giving it as BB, and 1200 is the address, and again we are giving that is CC. Here we are giving it as 21250, like this. So this is the head element. This point to 1200 and this is point to 1250. Simply we can say that singly linked list, and this is point to circular linked list. Then we can give it as 1000. Okay, 1000. So it will move to here. And if we want to delete the head element, the first element, then what we want to do? We can simply change the head element as 1200. Then it will delete this one, and here change this 1000 to 1200. So it will point to here. This will be automatically deleted. Clear? So if the list is empty, then element cannot be deleted, and if the element to be deleted is the first element, then make the start head pointer to the second element. Simple. Else delete the element from the list by calling find function, or return the found address of the element. So if you want to delete, simply if you want to delete the element in between, then what we want to do? So we can repeat it. This is the data value of AA and it is 0.1000. And this is the data value of BB and it is 0.1200. And this is the data value of CC, it 0.1250. So this is circular linked list. So this is 1000. We want to point the 1000 over here. So it will move to here. And here, from here we want to give the memory address as 1200. Here we want to give the memory address of 1250. So what we want to do? Here delete the element from the list by calling the find function and return the found address of the element. So circular linked list from which an element was deleted, dotted line shows the linked list existed prior to deletion. So we want to delete the first element. We want to delete this element. So what we want to do? Here instead of this 1000, we want to give the 1200 as the head. That's all. This is the deletion of the first element. Then again, anything is here? Else delete the element from the list by calling the find function and return the found element of the address of the found element. So this is I think one or two slides are there. So the application lists are used to maintain polynomials that we discussed in the first class, polynomial in the memory. For example, we have a function fx equal to 7x raised to 5 plus 9x raised to 4 minus 6x raised to 3 plus 3x raised to 2. So this is a figure that is 310 depicts the representation of a polynomial using a singly linked list. So it starts from 1000. So here the value, two parts are there in a polynomial contains two components. First one is the coefficient and the exponent, and the x is a formal parameter. I think all of you are familiar with formal and actual parameters. So x is the formal parameter. We are omitting x from here in the list. So for example, we have the function. So first part, what is the first part? 7 is the coefficient and 5 is the exponent, right? So we are giving the data value 7 here and 5 here, and it points to the next data value, that is next address 1050, and next part 9 and 4 points to next memory address, then 6 and 3 and 3 and 2. So this polynomial can be represented by using this doubly linked list. It's a singly linked list, right? Okay. Anyway, linked list, it's a singly linked list. So we can represent this polynomial by using this singly list. Linked list we can use. So this is the end of this slide. So the time is 10:25. I think it's the time for this is the end of this block and the arrays chapter, unit 3, the end of the unit 3. So this is the end of the unit 3, and next class we can start, even if it's a theory or practical class, we will continue our theory portions in the next class. So if you have any doubt, you can ask.